Um, I see. Hindi makita. Okay. Let's proceed. So we try to conduct this vulnerability assessment. So this one shows you the map when I intersect the flood and the land cover and the municipal jurisdiction. This one. So we generated the key vulnerable hotspots and we assess per elements at risk, like for example, high built up, high risk crack, high risk agriculture, low risk, um, examples like that. And the figures this, we actually delineated or defined population at risk with a total of around 70,000 population at risk during flood, and the larger population that is affected is at low and moderate. 50% is affected with the flood, and the 50% is male. There is a gender equality there. Um, for the risk assessment on flood, we actually explore on taking into account how much area or what's the area of agriculture area that is affected for flooding. So we actually do generate moderate flooding on the Lilio and the Carlan with 1,000, no, 2,000, more than 2,000 hectare of agroforestry. We explored also the anticipated loss due to flooding. So at a value of 49.9 kilogram rice fields at Santa Cruz, this one is Santa Cruz and Santa Cruz. Actually, the damage loss caused by by flooding is less than a billion of uh, loss in peso. So let's check on this, the nexus of interlinkages between climate change and vulnerability. This one is the settlement area along the water channel. This one is the rice fields. See, the riparian here is actually very impressive. Floodplains is still there. We'll see next strategy between climate change. Firstly, we examine the extreme rainfall combined with deforestation. That will happen, that will equate to enhanced erosion and siltation. So the impact on this was increased sediment flood loads downstream, irrigation canals and lake fish pens, reducing agriculture and aquaculture productivity. This is actually a clear ripple effect or cascade risk from the upland to lowland. And then if we see naman, and then if we see sea level rise, altered lake hydrology, that is, what happens is the flooding and saline intrusion. So the impact on this is a compounding flooding risk from the lake and backflow from the rivers. So it's just example of or enumerated problems when there is an erratic or anomalies to the climatic conditions affecting the biota, affecting the whole watershed also, especially our farmers. So the very important is everyone is studying about the societal welfare and everyone like that. So we want to take into account the socioeconomic vulnerability of the communities, especially those who are dependent on climate sensitive livelihoods such as farming and fishing. So these marginalized communities often reside in actually high risk areas like riverbanks, shorelines that can be said that low adaptive capacity. This the unplanned development increases impervious surface, exacerbating runoff, flooding while polluting the watershed. So to conclude, Santa Cruz watershed is a complex system of climate-induced environmental stress. So in the future, climate change threatens the exacerbates land degradation and water pollution, including the hydrological disruptions of the overall processes of the watershed. This diagnosis reveals that the most serious risk exists at the interfaces between upland and lowland, lake and river, and the human population and the natural systems. Thus, every element affects the other in the watershed system. So, how are we going to do that? We need to reduce this risk effectively so that we can manage the sectors adapting their adaptive capacity to enhance. Okay? This means that we need to consider all interactions within the watershed to create and to aim at a sustainable and resilient community. So for that, for our recommendation, we actually are aiming integrating approach of green and gray infrastructure supporting nature-based solutions, the ridge to rift scale, that while we need to strict compliance to the policy of a protected area, enhance the vegetation cover at the upstream, and maybe we need to put some attenuations or mechanism on how to trap the flood or collect the flood water in order to reduce risk of flooding at at the downstream. So actually, this study explores on how to introduce this underground discharge channel. This underground discharge channel is actually will store or collect water from rivers in order to be used in the future during El Nino. Farmers and other household use uh, will use this water as part of the adaptive mechanism during drought. So that's it. Where is it? The best place to put the discharge channel is here or here. So that anticipated to supply water for the irrigation of the uh, rice fields. And for that, I want to end this presentation. Thank you so much, Doc Dondi, Mark Arboleda, and thank you for to all the facilitating instructors of the ENS topics, ENS 201 topics, the insights and the guides and the um, the advice, the guides to the students is very helpful for us, and this very meaningful learning course. Actually, this one is very uh, helpful for me to understand and refresh everything, and it makes sense then because it, it adds up to my knowledge, and it's keeps me on the ground when it comes to taking into account the uh, environmental systems thinking. Thank you, Doc. Thank you, everyone. Good night po.